Welcome to 1.1 Linear Functions Part 1. In this lesson, you will identify families of functions, describe transformations of parent functions, and describe combinations of transformations. The first thing we need to do is talk about parent functions. So these are functions that share characteristics. And in this lesson, we're going to talk about 4 different types of parent functions. The first type is constant. It is in the form f of x equals some number, okay? And the parent function is f of x equals 1. It is a completely horizontal line. The domain is all real numbers. The domain is your x values. What kind of x values can you put into your function? Your range is y equals 1. That's the height of your function. That is your y values. The second type of function is a linear function. And you have probably the most experience with lines. And that's what we've been reviewing the past couple days. It's in the form of f of x equals something with an x in it. And this is the parent function. It's like home base. F of x equals x. It is a slanted line. The domain is all real numbers, and the range is all real numbers. That means it's as wide as it can be, and it goes as tall or as low. It includes all numbers. The next function is the absolute value function. The parent function is f of x equals the absolute value of x. And you notice the picture, it's in a V-shaped. Okay? The domain is all real numbers, and the range is y is greater than or equal to 0. One note, make your lives a little bit easier. The slope on this side is 1, and the slope on this side is -1. So that might help you draw your functions. The fourth type of function is a quadratic. It's in the form of f of x equals x squared. And this is U-shaped, okay? It is U-shaped. Notice the vertex is at 0, 0. The domain is all real numbers. That means it goes as wide as possible, but look at the range. The range is y is greater than or equal to 0. That means the y is bigger than 0. The height is 0 or above, okay? And that's what that means. It means it starts at 0 and it gets higher. It doesn't have any values below the x-axis. It doesn't have anything in the negative height range. So let's look at example 1. We need to identify a family function, or function family. Identify the function family to which f belongs. Compare the graph of f to the graph of its parent function. So right away, we notice that this is V-shaped. So this is an absolute value equation. Compare the graph to its parent function. So to do that, we need to graph it. And the parent function equation is, and we'll call this g of x. So g of x is equal to the absolute value of x. And we need to graph this. We need to graph it and just visually look at what's going on. Quick way to graph is to use a t-chart if you have no idea what this looks like. So we're going to pick some values. It doesn't matter what values of x you pick. I'm going to pick -2, -1, 0, 1, and 2. Now I'm going to take the absolute value of each one of those. Okay, and I'm going to do a little think cloud over here so you see what I'm doing. So g of -2 is equal to the absolute value of -2. Well, the absolute value of -2 is 2. And these we can really do in our head. So let's do it in our head. So the absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So let's graph these points. We'll make them red. So the point -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and that's what we got. So you notice that the slope of the right-hand side is the slope of 1. Remember we talked about that? And the slope of the left-hand side is -1. So you can totally do this and just do rise over run if you wish. So there's the parent function. Let's label that one. We called it g of x. And what do you notice? Visually, what do you notice? Well, we notice that the f of x went up 1 unit, so it moved up 1 unit. And you notice, like, look at the vertex, it went up 1 unit. And also it is more narrow. So let's just say that, more narrow than g of x. So it's more narrow than the parent function, okay? Later on, we're going to call this a vertical stretch, all right? So we have those two information. Now we need to talk about domain and range. All right, so the domain here, we're just going to put D with a colon. The domain, how wide does the blue function, the f of x function, go? Well, it goes as far right and as far left as you can possibly imagine. So this is all real numbers, okay? And a quick way to write all real numbers, if you don't want to write out that word every time, it's a double barred R. It means the same thing, just a shorthand version. The range is how high does your function go. And you notice the lowest possible height that gets is right here. That's as low as it goes, okay? And then it goes up from there. So the lowest it goes, we're talking about the y values, the lowest it goes is y equals 1. So the range, we can describe that with an inequality. Y is greater than or equal to 1. All right, let's look at example 2. Describing transformations. So a transformation changes the size, shape, and position or orientation of a graph. A translation is a transformation that shifts the graph horizontally or vertically. So in example 1, we noticed it shifted 1 unit up, but it does not change the size, shape, or orientation. So let's take a look. Let's look at the graph of g of x equals x minus 4 and its parent function. So right away we notice that there is only an x value. There's nothing weird going on with it. So this is actually a linear function. So let's write that. It's a linear. And the parent function, see, we already have a g of x, so let's call this parent function f of x. F of x equals x. So that's the parent function. It's like home base. So we're going to graph both of these and take a look, okay? Hopefully you'll be able to review how to graph these, and this is just a line. So you can make a t-chart if you want to, but I know this starts at 0, 0, and the slope is 1. So rise over run, I can just work that out and go back the other way. So this is the parent function. So it's a nice straight line. We will need to label this f of x. Then let's do g of x. Let's graph that in g. Remember, g of x is x minus 4. Now, if you remember from before, this is your y-intercept, and the number in front of here is your slope, which is 1. It's understood to be 1. So we'll go down to negative 4, and we're going to rise over run. So we'll rise 1, run 1, rise 1, run 1. Go all the way out, so we get this as accurate. Down 1, back 1, down 1, back 1. Keep on going that direction. So this is the graph of g of x. That is your function, and the red one is your parent function. So we need to describe the transformation. Now, this is kind of unique because lines, this could be described 2 different ways. Just pick one and go with it. So you notice that from the parent function, I went down 4 units. Okay? Now, if by chance you were one of these people that noticed that you could have also done right 4 units, you would also be correct. Okay? Just pick one and go with it. Linear functions are special in the fact that they're right, left, and up and down look exactly the same. So you just can describe them 2 different ways. Okay? Now you notice that the slope didn't change, so nothing else changed on this. We just moved it down 4 units. Now let's talk about domain and range. Domain, how wide does the yellow function, the g of x, get? Well, it gets as wide as you can think about. Farthest to the right and farthest to the left. It goes forever. So this is all real numbers, and I'm using that double-barred R symbol because I'm lazy. And you can be lazy too with that, okay? All right, the range is how high and how low does your function get? Well, if you look off to the right, it goes higher and higher and higher, and my guess it will go higher forever. And then if you go to the left, it gets lower, lower, and lower forever. So it gets as high and as low as possible as you can think of. So this is also all real numbers. It goes to positive infinity down to negative infinity. As high as you can think about and as low as you can think about. Okay, let's talk about reflection. A reflection is a transformation that flips a graph over a line called the line of reflection. Remember this from geometry. You guys did this in geometry, okay? We either flip it over the x-axis or we flip it over the y-axis. So you have to kind of pay attention to that. So let's graph these two. Let's graph the p of x and the parent function. Now, since I don't know what this looks like, I know the parent function, it's a quadratic, right? Because I see that x squared there. So we'll call this one f of x, the parent function equals x squared. That's home base, okay? So x, and we'll just do this f of x, so we can't keep them straight. So this is the parent function. Pick some points. My favorite points to pick is -2, -1, 0, 1, and 2. If that doesn't do it and you need more points, you can always add more. That's the beauty of the t-chart. So I'm going to plug in -2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Now, a little side note. When you square a negative number, so you put it in the function. So this is -2, the whole thing squared. This is +4, okay? But look at when we do this, p of x. We'll make it green. So x, p of x. Pick the same numbers. If you look at p of x, that negative is on the outside. And order of operations tells us that we square first and then we take the negative. So every single one of these values are going to be negative, okay? So when I plug in -2 and square it, -2 squared is +4, and you bring down that negative. So the answer is -4. And this then becomes a -1, 0, -1 squared. 1 squared is 1. You take the negative of that. 2 squared is 4. Take the negative of that. And those are our points. So let's graph those. -2, -4, -1, -1, 0, 0, 1, -1, 2, -4. We're going to connect those with a nice smooth curve. This is U-shaped. Now let's graph the parent function. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And this is f of x. Remember, label, label, label. And this is p of x. So you notice that this is a reflection over the x-axis. It just gets flipped down. So we need to describe the transformation. So it's the reflection over the x-axis. Just flip down, right? Now we'll describe domain and range. Now, how wide does it get? That's domain. Well, it goes far to the right and far to the left. Talking about the green function here, okay? So that is all real numbers. It goes both directions forever. The range, how high does it go? Well, actually, it has a maximum height. It only goes up, oh, whoops, highlighter. It only gets as high as, I'm talking about the y values, as high as 0, but then it goes as low as possible. So to describe this, we say y is less than or equal to 0. So we talk about inequality, okay? So that's how we describe the range on that one. That's all we're going to do for today. The rest we'll cover in the next lesson. See you later.